Here are the notes that go with Lesson 6-6. This is the last lesson that's in Chapter 6, so please expect a test coming up next week. This lesson is about mixed expressions. Number 1, study example 1 on page 270 as a reminder of what a mixed expression is. Here in the Chapter 6 PDF is the lesson about mixed expressions. And take a look at example 1. Write 2 3/4 as a fraction in simplest form. And you notice where the authors have done that. They have separated the whole number 2 from the fraction 3/4, writing 2 plus 3/4. Then they wrote a 1 underneath the 2 so that that whole number 2 looks like a fraction, 2 over 1. And now they have an adding fractions problem, 2 over 1 plus 3/4. Then in the next step, they figured out that they wanted the LCD to be 4, and they added the fractions, getting 11 over 4. At the bottom of the screen is the definition of what a mixed expression is: the sum or difference of a polynomial and a fraction. A mixed expression is the sum or difference of a polynomial and a fraction. So number 1, we looked at example 1. You can check that off. Number 2, write this mixed expression as a fraction in simplest form. Following through the procedure that we saw in example 1, the authors first wrote 3 plus 1/5, and then in the next step wrote 3 over 1 plus 1/5, and then in the next step determined that the LCD of a 1 and a 5 is 5. To make the first fraction have a 5 in the bottom, you would times by 5, and in the top. 3 times 5 is 15 over 5, plus 1 over 5, and so the answer is 16 over 5. Now in elementary and middle school, you learned a shortcut way to get 16 over 5. It was to multiply the 5 times the 3, getting 15, and then to add the 1, getting 16, and to keep the denominator of 5. But why does that shortcut work? So behind the scenes is this process here. Now number 3, what do the textbooks say that a mixed expression is? It is the sum or difference of a polynomial and a fraction. Number 4, study example 2a and 2b. What is the very first step that the authors are doing? In example 2a, we can see that the authors are writing the c as c over 1, and that creates an adding fractions problem. In example 2b, we can see that the first thing the authors do is write the whole number 5 as the fraction 5 over 1, and that's so that it can be a subtracting fractions problem. So the first step is to take the whole number part of the problem and put a 1 as its denominator. Number 4, write a 1 as the denominator of the polynomial. Or in the case of example 2, it wasn't a polynomial so much as just being a whole number. Number 5, true or false? The second step of simplifying a mixed expression is to rewrite the fractions using the LCD. You could take a look at example 2 in the book, or even take a look at the example that we worked at the top of this note page, and you see that that is the second step, where I decided I wanted 5 to be the LCD, and so I multiplied the first fraction by 5 in the bottom and 5 in the top to make the transformation. Number 5 is true. So with these two steps, let's try some examples. Question A, what is 2 plus 4 over a? The first step is to write it as 2 over 1 plus 4 over a. The second step is to make the fractions have an LCD. So what is the LCD? If there's a 1 in the bottom and an a in the bottom, the LCD is 1a, or just a. For the first fraction to have an a in the bottom, we need to multiply by a and in the top. 2 times a is 2a. And the second fraction already has an a in the bottom, so we don't need to make any changes. Now that we have the same denominator, you add the numerators and keep the denominator. Question B, negative 5 2/9. It is understood that the negative applies to the 5 2/9. So you need to think of it like this. Now, you can use your shortcut method if you remember how to do that from elementary and middle school, or you can run through the process here with the changing to a common denominator. I'm going to run through our high school algebra process for the practice of doing it. There is a negative at the beginning. Now, in the parentheses, 5 2/9 can be separated as 5 plus 2/9. Next step, put a 1 under the 5. Now, what is the LCD of 1 and 9? It is 9. For the first fraction to have 9 in the bottom, you need to multiply by 9 and in the top. This becomes negative, and then in parentheses, 5 times 9 is 45 over 9. And the second fraction stays as 2 over 9, and this is equal to negative 47 over 9. The shortcut way is to go 9 times 5 is 45, plus the 2 is 47 over 9. Question C. The first step is to rewrite, and you take the whole number part and put a 1 underneath it. Now you have adding fractions. The next thing you do is you decide what is the least common denominator. If one denominator is b plus 1 and the other denominator is 1, then the least common denominator is just 1 times b plus 1, or just b plus 1 for short. The first fraction already has the least common denominator. We don't need to change it. The second fraction is missing the b plus 1. So we need to multiply by b plus 1 in the bottom and in the top. This makes b over b plus 1 plus b plus 1 over b plus 1. Now that we have the same denominator, we add the numerators. B plus b is 2b, and then the plus 1, all over our common denominator. Question D. What was step 1 when you have a mixed expression? It was to take the polynomial part and give it a denominator of 1, and then to copy down the fraction part. Now figure out the least common denominator. If one denominator is 1 and the other denominator is y minus 5, then the least common denominator is 1 times the y minus 5, or just y minus 5. First fraction does not have the LCD, and so we decide that we're going to times by y minus 5, and in the top. The second fraction already has the LCD. No changes are needed. Now let's work with the first fraction. A little bit of distributive property here and here. 4y times y is 4y squared. 4y times negative 5 is negative 20y. All over our LCD. and then a minus sign, not an adding sign this time. The second fraction already has the correct denominator, so don't change it. Now we can perform the subtraction. In the numerator, we have 4y squared, and then we also have a negative 20y minus a 1y. That makes negative 21y all over our common denominator. Question E. This is a mixed expression. It has a whole number part, but it also has fractions. So how do you do a mixed expression? What are the steps? The first step is to rewrite the whole number by putting a 1 underneath, and then copy the fractions. What is step 2? Step 2 is to find the LCD. There's got to be a 1 in the LCD, and also an x minus 3, and also an x plus 3. The LCD has to have all of the factors that you see in denominators. You don't really need to write the 1 down, but you definitely need to say x minus 3, x plus 3. Now let's change all the fractions so that they have that denominator. So the first fraction is missing the x minus 3 and the x plus 3. And you need to multiply the top by that as well. Now the second fraction in black ink. What is it missing in the denominator? It already has the x minus 3. It's missing the x plus 3. And times by that in the top. Now the third fraction. What is it missing in the denominator? It's already got the x plus 3, but it's missing the x minus 3. Okay, now let's do work in the numerator. Start with this piece right here. We need to figure out what that makes. It's 2 times x minus 3 times x plus 3. That's going to make 2 times x squared minus 9. And that will all be over our LCD. Now there's a subtraction sign, not an adding sign. Okay, now let's work with this piece. Do the distributive property. You get x squared plus 3x. And that's all over the LCD. Now there's a minus sign again. Now work with this part. This makes x minus 3. And that's all over top of our LCD. Now, are we ready to subtract all our numerators yet, or is there still more simplifying that needs to be done? Take a look at this first part. We haven't yet actually times the 2 to the stuff in parentheses. So this is the same thing as 2x squared minus 18. Now we're ready to combine all of the like terms in the top. Remember that you have subtractions as you're doing your combining like terms. So 2x squared subtract 1x squared makes x squared. There is a subtraction and a 3x. That's negative 3x. Then there's another subtraction and an x. So negative 3x subtract another x is negative 4x. Now the constant numbers. What constant numbers do you see? There's a negative 18 in the first fraction. There's no constants in the second fraction, but the last one has a subtraction and then a negative 3. We got to do negative 18 subtract negative 3. We want to get that correct, not mess that up. This makes negative 15. And that's all over our LCD, which was x minus 3, x plus 3. This concludes the notes for lesson 6-6. To add and subtract mixed expressions, step 1, write a 1 under the whole number or polynomial part so that you have fractions. And then step 2, get an LCD so that you can add or subtract your fractions.